Hi everyone, it's Mrs. Summer here to talk about Lesson 305, Balancing Chemical Equations. The objectives for today are students will be able to model the law of conservation of mass by balancing chemical equations using coefficients. Chemical reactions, if you remember, occur when bonds between atoms are broken and new bonds form, involve the making of new materials with new properties, and also involve energy changes. They are written as chemical equations. The coefficients tell you the number of each molecule. Subscripts tell you the number of each atom. And then the conservation of matter, or the conservation of mass, is that matter cannot be created or destroyed during a chemical reaction. It can only be rearranged. Because of this, a chemical equation must be balanced. But what does it mean to have a balanced chemical equation? A chemical equation is balanced when the ions or atoms found on the reactant side of an equation are identical to those found on the product side. So for example, we have magnesium plus oxygen reacts to form magnesium oxide. If we write our chemical formula correctly, or chemical equation correctly, we would have magnesium plus O2, because remember, oxygen is diatomic, reacts to form magnesium oxide. And with a balance, it would be 2Mg plus O2 yields 2MgO. Because now, with the coefficients in front, we have 2 magnesiums, we have 2 oxygens on the reactant side. And on the product side, because of that coefficient, we have 1 Mg here and another Mg over here, which is total of 2. We also have 1 oxygen and 1 oxygen. Like most things, there are some rules that you have to follow to balance chemical equations. So when balancing a chemical equation, you can add or change the coefficients. You cannot add or change the subscripts. Reiterating this, you cannot add or change subscripts, only the coefficients. So because if you change the subscripts, you're changing what the compound is. And it's no longer what you think it should be. You can only change the coefficients. It's similar to adding like terms in math class. If you had x squared plus 3x squared, that does not equal 4x to the fourth, correct? No, it doesn't. It does equal 4x squared. You added the coefficients in front of the x's, but you didn't add the exponents when you were adding like terms. So steps to balancing equations. Step 1 is if you are given the question in words, you must write the correct formula for the reactants and products. There will be many times, at least in our class, where you're already given the unbalanced chemical equation and you don't have to write it from words. But if you are given it in words, you need to just write the reactants and the products. But don't try to balance it yet. Write the correct formulas first. And then once you do write them, once you write them correctly, don't change the formulas. So in this example, we have sodium and chlorine react to form sodium chloride. And if you recall, that react to form is the yield sign. And sodium is Na, and chlorine is Cl2 because chlorine is diatomic. And then we have our yield sign. Sodium chloride is just NaCl. So step 2 to balancing equations is draw a table underneath the reactants and the products. Then you find the number of atoms of each element on the reactant side. You find the number of atoms of each element on the right side. And then you compare the two. So in our example, sodium here has 1 on the reactant side. Chlorine has 2 because of that Cl2. On the product side, sodium has 1 and chlorine has 1. So as you can see, comparing these two tables that you made, chlorines are not balanced. They are not the same on the reactants as they are on the products. Step 3 is start placing coefficients in front of formulas. So start placing coefficients in front of the formulas. Retotal the number of each atom every time you place a coefficient. And it's a trial and error process. You'll do one thing and it'll change, and then you got to go back and change another, and that's okay. You just keep doing this process until you get the same number of reactants as you have on the product side. So in this example, I started by placing a 2 in front of the NaCl. And when I did that, I no longer had 1 sodium and 1 chlorine. I had 2 sodiums on the product and 2 chlorines. Well, now my chlorines are balanced, if you see 2 and 2, but my sodiums are not. I now only have 1 sodium on the reactants, but I have 2 on the product. So then what I did was I went and I put a 2 in front of the sodium. By doing that, I crossed off that 1 on my reactants and I put a 2. And so now if you look at the two, comparing them, I have 2 sodiums on the reactant, I have 2 sodiums on the product. I have 2 chlorines on the reactants, I have 2 chlorines on the product, and it is balanced. Step 4 is to check to see your answer to see if the number of atoms on both sides of the equation are now balanced. And also that the coefficients are in the lowest possible whole number ratio. So let's say you were doing this and you ended up putting a 4, 2, and a 4. Well, that's technically correct, but it's not in the lowest whole number ratio. And so by doing that, you can reduce that by putting a 2 and a 1 and a 2. So make sure that they are in the lowest whole number ratios as well. So here's an example. I want you to try it. Make sure you pause the video. You can also rewind the video in order to go back to look at the notes again. You try this example and type your answer into the Edpuzzle question box. So let's review that example. We have S8 plus O2 yields SO3. So on my reactant side, I have 8 sulfurs. On my reactant side, I have 2 oxygen. On my product side, I only have 1 sulfur. And on my product side, I only have 3 oxygens. So both elements here are not balanced. A tip: balance oxygen last. It's a tip for all type of balancing questions. Balance oxygens and hydrogens last. In this case, there's only oxygen. So let's start by balancing our sulfurs. By doing that, so how do I get 8 and 1? Well, I need to put an 8 here. Let me just change that to a different color. So I have 8, and so now my product numbers change. So instead of 1 sulfur, I have 8. Instead of 1 oxygen or 3 oxygen, I have 8 times 3, which is 24. So now if I look across, both my sulfurs are balanced, but my oxygens are not. So then I have 2 oxygens. So what can I put in front of oxygen to make it 24? I can put a 12. And now I have 24 oxygens. I have 8 sulfurs, 24 oxygens. So if we look at this, this is balanced and the oxygens are balanced. So this whole thing is now balanced. And here's just a different way of looking at this, better than, Mrs. Summers' handwriting.